So let us round up. Right. So I'm going to share my screen. Now, we're now back to complete our last session. Okay. All right, probability distribution. So now let's start with the random variable. I'm sure I've explained this at the beginning of the semester, what random variables, type of variables we have: discrete, continuous, random. Now, random is any variable that has a value that are determined by chance. For example, if a dice is tossed, the outcome can be 1, 2, 3, 4, 5, 6, and yeah, showing up. Nobody have control over that. You know. Now, number of siblings that anybody in this room have, none of us have control over that. It's a random variable. Now, at the time the bus arrive at bus stop, 5 minutes, 10 minutes. Sometimes they have a time, a specific time, but sometimes, most times they don't arrive at that specific time, either a few minutes before or a few minutes after. So any variable that has values that are determined by chance, we call it random variable. Now, for discrete random variables, they can be counted. They have values that can be counted. For example, number of joggers at Patterson Park. You can have one person jogging, 2 people jogging. You cannot have 2.5 people jogging. You can have either 1, 2, or 3. So it's a countable. The number of eggs a hen can lay in one day: 1, 2, 3. You can count eggs, but not measure eggs. Number of calls, number of calls received after a TV commercial: 1 call, 2 call, 3 call. You can't say 2.5 calls. Not possible. Number of sales calls a salesman make in one day. These are all countable values. So they call them discrete random variables. Now, for continuous random variables, they are not counted. They are measured. Things like height, temperature, voltage, and so on and so forth. Now, discrete probability distribution consists of the values a random variable can take or can assume and their corresponding probabilities. Now, look at an example of discrete probability distributions. We have binomial distribution, Poisson. There are others, but we will focus on binomial especially. We also have continuous probability distribution, normal and normal distribution, and uniform distribution. Okay. At this point, we can now look at some examples. First question says, construct a probability distribution for rolling a single dice. For rolling a single dice. Solution. You all know how a dice looks like. It's six sides. They ask to construct the probability distribution for only a single dice. So let me show you how to do it. First of all, you have to remember that a probability distribution simply means the values a random variable can have and their corresponding probabilities. So for this case, we have a single dice. So we have outcome X, and then the corresponding probability of X. So outcome X, which is your X, and the probability of outcome, Px. Okay. So for the dice, you have 1, 2, showing up, 3, showing up, 4, showing up, 5, showing up, and then 6. They're gonna have total. Okay. Okay, this can be put in this form. So for each outcome of this distribution we have for 6. The probability of 1 showing up is 1 out of 6 chances, because the dice have 6 sides. For 2 showing up is there's only 1, 2. For 3 showing up 1 out of 6. For 4, 1 out of 6 chances. For 5, 1 out of 6 chances. For 6, 1 out of 6 chances. So our total will be, if you add all these ones, you're going to get 6 out of 6 chances, which is 1. 6 divided 6 is 1. Everybody in Baltimore knows that 6 divided 6 is 1. Question on this? Any question to this?
Professor.
Yes, ma'am.
Okay, you had the numerator together. That's how we got the 6 divided by 6, right?
Yeah, because numerators are the same. So that means we have 1 plus 1 plus 1 plus
1. Okay, I got you.
Now let's see more. Another way this question can be asked. It says here that the results, during the small months, a rental agency keep track of the number of chainsaws it rents each day during a period of 90 days. Number of chainsaws rented per day is presented by the variable X. Results are shown here. The answer, the question says compute PX, that means probability of X. Okay. And for each X, and they say construct the probability distribution and graph the data. So let us start from here. Please mute yourself if you don't mute yourself wherever you are. I'm gonna move this down so we can have room. Okay, good. So part A is a mute. Let's get this together. Have X. So and then number of days. So let us calculate PX. We need one more line so we can get a total. And one more line from here. Okay, PX. Now we have an extra line here, total. So you can get our total right there. So that we move this PX, probability of X to PX. Now let's add this to get the total of these numbers. Excuse me. Now we have this 5. We get
that's 90. Huh? 90.
Add all this till you get 90. Correct. 90. Yeah. Now we can now solution is to part A is to find the PX. For the first one, probability of 0 is P0 will be, for 0 we have 45. I mean 45 out of 90. 45 divided by 90 should be half. But let me just show you. That's 45. 45 by 90 is half. This is 0.5. 0.5. So we write 0.5 here for PX. 0.5. Now, 0.5 here. Now, next one is to get the probability for 1. So that's P1. P1 will give us, for 1, we have number of days is 30. So 30 by 90. The total is 90. P1 will be 30 by 90. 30 by 90. 0.33. You keep going, just use 0.33. 0.33 is good enough. 0.33 0.33. And C number 2, probability of 2 will be, I didn't put 0.33. I'm going to put 0.33 here for 3.33. For 2, we have equals 15 over 90. For 90. 15 over 90 will be
0.17.
0.17. Okay. Right, so you got this got 0.17. So now adding all this together. Please mute yourself. Mute yourself, please. So have 0.5 plus 0.33
equals 1.
Plus 0.17 is 1. So you can see that they add to 1. Okay. They add to 1.0. So now we are answer part A. Part A say compute PX. So these are the PX. See? And they say construct a probability distribution and graph the data. So part A say compute PX. This is the computation of PX. And for the, you say part B say construct a probability distribution. This is it right here. The values and their corresponding probabilities is what makes up the probability distribution. So we are answer part A and B, but it says part of part B say graph the data. How do we graph it? You graph the axis versus the probability. So I'm going to show you in Excel how I graphed it. I'm using Excel to graph. If you're in the classroom, I'm going to use a regular graph, but since I'm using remotely, I recommend that you use Excel. As I have the numbers here already, I can just highlight it. You can see the number of cells rented. Let me make it bigger. Make it a little bit bigger. Matter of fact, here. You can see right there. So number of cells, I can go from here and insert the graph. I think I should use this one. Let me use the one. You can see right here. And then put the axis. Number of chain cells. Okay. Number of let me have what we have. Okay, number of chain cells. Okay. Of chain cells. The chain saw. Okay. Rented. And the probability right there. Probability. So this is the bar graph. Okay, for a chainsaw data. And usually, you know, if you like, you can make it a histogram if you want by expanding this. So otherwise, you just say graph. This is the graph right here. And you can see that as the number of the chainsaw increases, the probability is basically it is not a symmetric, right skewed. So you can copy this and paste it in your work, especially if it's a project. And here's our graph right here. Questions? Any query? So we went from here, from calculating the probabilities. Here I'm getting the probability distribution to graphing it. Any question for this? Yeah, excellent. Now, two requirements before we can say that it is a probability distribution. There are two requirements. The first requirement is that the sum of the probabilities of all the events in the sample space must equal 1. You can see that all the probabilities here are 1. You add them here, you get 1. this first one we did, we added and we get 1. So that qualifies them to be a probability distribution. The second requirement is that the probability of each event in the sample space of each event must be between 0 or 1. This means that it cannot be a negative number. The probability of each event can never be a negative number, or it cannot be bigger than 1. So these are the 2 requirements. Based on these requirements, what do you think? It says determine whether each distribution is a probability distribution. Let's see. Let's test the first requirement, solution. So that in this case, say the sum of the probabilities of all the events must be 1. So that means sum of probabilities. Will be equal 1/5. You can see the probabilities right here. For 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5 equals, if you add all the ones, 1, 2, 3, 4, 5, 5/5, which is 1. So the answer is it passed the first test. Yes, because the sum of the probabilities equals 1. Do you agree? Hello?
Yeah.
Excellent. So let's look at the second one. Second one says, let's see if it says, now this one you don't even need to know because it failed the second requirement. Second requirement says that the probability of each event cannot be a negative number or 1. So you can see that this is negative. This is bigger than 1. So the answer is no, because one of the probabilities is a negative value. Another one is greater than 0. So greater than 1. So I may see the one that is 1.5. You can see right here. So that automatically disqualifies it because it failed the second requirement. Question on this? Any question?
No.
Okay. The third one says, how about this one? Okay. Let's see. Now, the answer, the question, there are infractions. And this time, unlike this first one, where we can just simply add the numerator. This is a simple, or they all have the same denominators. So you can just add the numerator. But here, they have different denominators. So you have sum of probabilities. Probabilities equals 1/4 plus 1/8 plus 1/16 plus 9/16, which for your algebra class. For your algebra class, you can how you get the LCM and all this stuff. But we can get it with a calculator real fast, since this is a statistics class. So I got 1/4. Okay, excuse me. 1/4. Okay. Plus 1/4. Sorry, 1/8.
Professor, we can't see the calculator.
You can't eat? Oh, excuse me. Sorry. So 1 over 8. Can you see it now?
Yes.
1 over 4, okay, plus 1 over 8 plus 1 over 16 plus 1 over, sorry, mistake, 9 over 16. 1, they add to 1. So that answer is yes. Of course, you know why, right? You know why this time?
Yes.
Because they add to 1. So the answer is yes. So that's how you get it. I leave this one for you as a practice. Try it as a practice. Okay. Question on this? Any query? Excellent. Okay, good. Now another way you might see this kind of question here. You might be given this value. It says determine the required or missing value of B to make this distribution a discrete probability distribution. So they give you all the value, but they didn't give you this one. It says B. So to find B, all you have to do is this: to subtract everything from 1. Okay. Which means that we have B equals 1 minus 0.41 plus 0.02 plus 0.35. And that will give you the answer for B. This one is so simple. Okay. So I'm gonna put this in. Write this down. So I have 1 minus 0.41 plus 0.02 plus 35. So the answer will become, let me put it calculate. 1 minus 0.41 plus 0.02 plus 0.35 plus I didn't put the point here. 0.35 plus I think that's it. Oh, that's it. 0.22. This is 0.22. So a B is 0.22. So point. That's it. So at this point, we start to look at the mean, the variance, and standard deviation of a probability distribution. Okay. The mean is formula is, of course, the mean have the symbol mu. X times px, sum of x times px. Variance is, which is represented by delta square, is sum of x squares times px minus mean squared. And standard deviation is square root of variance. So we can apply this to this example here. Say a bank president show that each savings account customer has on average 3 credit cards. The following represent the number of credit cards people own. Yeah. Now it says find the mean, variance, and standard deviation. And then is the president correct? Well, let's see. First thing you do is to put this, get this the values for get the table of values. Now there are another way of doing it, the horizontal method. But I'm going to show you the shortcut method for doing this. The shortcut method is to make a table of values. Okay, solution. X. So we have to get table of values. 1, 2, 3, 4, 5. Let me use this. Okay. You need the number of credit cards, X. Credit cards, which is your X. Then the probability of X, which is a PX. Okay, I'm gonna make it a little bit dense. Now, if you look at the mean, I'm gonna say X times PX. So you get that part. So X times PX. Now, when you look at the variance, it says S squared times PX. That means the minus mean square. That means you need to get S squared. S squared. The X squared, which is in this form. Okay. Then another thing is this part. S squared times PX. You get that S squared times PX. X squared, yeah, times PX. So that means we don't need this column here. We don't need. So this is what we need to put. This is what we need to get in the table of values. Yeah. So now we count number of cards. We have 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, and then total. Yeah, I can put this in order. PS is given already here. 0.18, and I have it. I think I have it on my book. Yep, I have it on my book. 0.18 and 0.44. 0.18, 0.44, 0.27, 0.08. Okay. 4 is 0.03. Do we have 5? No, it's stuck at 4. Okay, so I'm gonna move this 5 and get a total. Now, S times PS means this times this. This is X times PX. Okay. So 0 times 0.18 is 0.00. 1 times 0.44 is 2.44. 2 times 0.27 will give us, I got it, 0.54. And 3 times 0.08. Double check this with your calculator. 4 times 0.03 give us 0.12. Now for X squared, you can square all this. 0 square means 0 times 0 is 0. 1 square means 1 times 1 is 1. 2 squared, that's X squared. 2 square means 2 times 2. 3 square means 3 times 3. 9. 4 square means 4 times 4. 16. Then okay, we have 10 minutes left. So what I'm gonna do, we're gonna continue this tomorrow. And when we come tomorrow, we start from here. We'll read the question again and continue from where we stopped here. Okay, and finish it up. Okay. Let me use these 10 minutes to take your attendance. I'll finish, and then if you have time, we can round it up. Okay. Let me take your attendance. Okay.
Professor, can you just scroll up a little bit for me?
Let me bring it down so that it will be on one page. That should be better for you. What do you think?
Yeah, I even want to see the formulas.
Formula, you want to see the formula? Right here.
Yes, thank you. Yeah. Thanks.
Hi, Christian name. Fumilayo. Fumilayo is okay. She's here. This is 12, 29, 21. Right. 9.
Did you get my attendance already?
Lion?
Fumilayo Bello.
Yeah, you can, yes, you can leave now.
Okay, thank you. Good night.
Abimbola Oshu.
I'm present, sir.
It's Olubusi.
Present, sir.
What's today? Huh? What's today?
Olubisi present, sir.
Mommy, what's today?
Now, Adenike.
Present.
So I see you tomorrow. I got Brandy.
I'm here.
See you tomorrow. I got Wemi Shola.
I'm here.
Tomorrow. Who else? Halimat.
I'm here, Professor.
So you can go see you tomorrow. Hey, is Harris?
Yes, I'm here.
I see you tomorrow, okay?
Okay, tomorrow.
Who else? Hedi.
Yes, I'm here.
How you say your name? Hedi, right?
Haiti.
Did I say it right?
Yeah, Haiti.
Oh, Hedi. Okay, Hedi. Okay, Hedi. So I see you tomorrow, okay?
Okay, bye-bye.
Goodbye. Kristen.
Yes, I'm here.
Miss Kristen, I see you tomorrow.
Okay, see you.
Sure. Who else? All right. I got Miss Lionel.
Yes, Prof.
Lovelace.
I'm here.
Mr. Lionel, I see you tomorrow, okay?
Okay, Prof. See you tomorrow.
Then, Lizzie.
I'm here, Professor.
I see you tomorrow, Miss Lizzie. I see you tomorrow, okay? Lovelace.
God bless. Good night.
Yeah,
Yes.
Rochelle.
Have a good. Lovelace is here. Have a good evening, Professor.
You too. Rochelle. Rochelle, you there? Nicholas?
I'm here.
That's
Good night.
I think I called Abati. Abati, you there?
Yes, I'm here.
See you tomorrow. Miss
night.
Castillo, you there? Castillo, Sarah.
Yes, I'm here.
That's why I see you tomorrow.
Did you hear me, Professor?
Miss Castillo, yes, I did.
Okay, thank you.
I see you tomorrow. Shavana Graves. Tyree. Tyree, there?
Tyree is here. Have a good night. This is Tyree.
Tyree, okay, good night, good night.
Good night.
Devonda.
I'm here.
Tomorrow.
You heard me?
I did.
Okay.
See you
Okay, good
tomorrow.
night.
Good night, yeah.
All right.
I think I have everybody. Did I miss anybody? No. Olubisi, I called you, right? Yes, I
Okay,
did.
you called me. Okay, I want to be sure because I don't not
I
sure.
called you
Okay.
already. Yeah.
Good night, sir.
Good night.
Professor, will you fix the Excel number print?
Yeah, it will be ready tomorrow. I will fix it tonight. But it's gonna be like midnight. Just check it again. Check it again tomorrow. You're talking about
Okay.
Excel assignment 3, right?
Yes.
Right or wrong?
Yes, right.
Yeah, tomorrow it'll be there. Don't worry.
I have a question, sir. How
Sure, go
many
ahead.
questions is our test? How many questions?
Your tests. Let me
Yeah.
see. Let me see. I can I don't know if I can open it from here. Let me see. I think it's about 15 questions, I believe.
Yeah, because I was trying to check it and I opened something say continue, but I didn't click the continue. So I just want to know the how many questions before I just open it. Thank you.
I think it's about 15 questions. Yeah.
Okay.
Another question, Professor. So you mentioned something about Excel number 1, but we didn't have number 1, just 2
Yeah.
and 3.
Just 2 and 3. Start 2 and 3 are good because it's part of the project. So the project is basically the one.
Oh, okay. I want to make sure. Thank you so much. Good night.
Good night. So I'll see you guys tomorrow, okay? What else? Miss Graves, do you have a question for me? Miss Graves. All right, so I'm gonna end this.
I'm sorry, Professor. I had to step away for a second.
No problem. I've already called your name, so you should be good.
Okay, thank you.
Okay, see you tomorrow.
Have a good night.
You too.